In this lecture, we're going to discuss hemodynamics. Your blood pressure is the outward force that the blood exerts on the walls of the blood vessels themselves. Your blood pressure can vary dramatically in different parts of your vascular system. Your arteries are under much greater pressure compared to your veins. The blood pressure itself is one of the forces that helps keep the blood circulating in between the heartbeats. And even though our heart beats fairly quickly, there is still the fact that your blood has to go all over your body before it returns through the venous system, and your blood pressure helps keep it flowing smoothly. Now, the magnitude of your blood pressure, okay, or if you want to think about the numbers, the systolic, the diastolic numbers, the 120 over 80, that number, that magnitude, it's one of the main determinants of the blood flow itself, okay? And it also has to do with how much blood is flowing per minute, or the volume of blood. All of those kind of correlate with one another. Generally, your blood flow matches your cardiac output. We have discussed cardiac output previously. This averages between 5 and 6 liters per minute. We have also discussed how you can change your cardiac output through sympathetic or parasympathetic stimulation, things like that. So this number can change. This is just an average. Your blood flow is directly proportional to the blood pressure. Okay, so as blood flow increases, your blood pressure increases. Okay. Blood also flows from a high pressure to a low pressure, so this is the most familiar way that things flow in the body anyway, so this should make sense. We did also mention that your arteries are under a greater pressure than your veins, and your blood flows from your arteries to your veins, so this should hopefully make sense. Now, there are three main things that affect your blood pressure. We have peripheral resistance, cardiac output, and blood volume. The peripheral resistance itself is anything that hinders, okay, or makes it harder for your blood to flow through the vasculature itself, so the vessels themselves. And we can kind of change our peripheral resistance in a couple of different ways. If your peripheral resistance increases, your blood pressure increases. If your peripheral resistance goes down, your blood pressure goes down. Okay, so this is a direct correlation. So let's talk about some things that can affect peripheral resistance. Okay, we have three different ways that we can modify peripheral resistance. We've got the blood vessel radius, blood viscosity, and blood vessel length. Your blood vessel radius. We have discussed previously that we can vasodilate and vasoconstrict the blood vessels themselves. So we can either increase the radius or decrease the radius of the vessels. If you increase, where's my little thing? Here we go. If you increase, if we vasodilate, we are going to reduce peripheral resistance. If we decrease our radius, we are going to increase peripheral resistance. So this is an inverse relationship here. Okay. We could change blood viscosity. Okay. We have mentioned blood viscosity previously as well. This really refers to kind of how thick your blood is. We can increase viscosity if we increase the number of proteins or cells within the blood itself. So we talked about polycythemia previously when we had increased red cell production, and we said the classic too much of a good thing isn't a good thing. We said, you know, you would have increased oxygen carrying capacity if you had more red blood cells, but it would increase your blood viscosity. We mentioned that that was bad. This is why it's bad. Okay, the thicker your blood is, the harder it is to move through the vessels. It does increase peripheral resistance, which you have just learned increases your blood pressure. So that's kind of a negative. And then last but not least, the blood vessel length affects peripheral resistance. The longer the blood vessel, the greater the resistance. Now, we can't exactly extend or shrink our blood vessels. That's kind of weird to think about. But if you are sending blood through a longer vessel, it would have a greater peripheral resistance and therefore a greater blood pressure compared to a shorter blood vessel. So these three things ultimately affect your peripheral resistance. And remember, your peripheral resistance goes up, your blood pressure goes up. Now, number 2, we mentioned your cardiac output has an effect on your blood pressure. If you remember, cardiac output was your heart rate times your stroke volume. Okay, so how quickly your heart beats times how much blood you're pumping out of your ventricles with each beat. That was your cardiac output. Okay. Your cardiac output directly affects your blood pressure, okay, which is this delta P. Okay. We have to take your cardiac output and we multiply it by your peripheral resistance. Okay. So these are directly affecting your blood pressure. Okay, so when cardiac output goes up, your blood pressure goes up. When peripheral resistance goes up, your blood pressure goes up. Okay, these things are directly correlated. So again, just in case you've forgotten, heart rate is how quickly we're beating per minute. Stroke volume is how much we're beating per minute. That's your cardiac output. If your cardiac output goes up, blood pressure goes up, and vice versa. And we just talked about peripheral resistance going up will directly increase your blood pressure as well. Okay, so these are all direct correlations. Okay. Now, last thing is blood volume. Okay. Your blood volume is directly linked to the amount of water that you have in your blood. Hopefully you remember that the majority of your blood is plasma and the majority of your plasma is water. Okay, so when your blood has more water, your blood volume goes up. When your blood volume goes up, your blood pressure goes up. Okay, so if you are nice and hydrated, okay, you are going to have a nice amount of water in your blood. Your blood pressure will hopefully be nice and stable. If you are dehydrated, okay, if we do not have enough water in our blood volume goes down, and this will cause your blood pressure to go down a little bit. Okay. Now, let's put it all together. This is a very nice picture for you to review over and over and over to make sure you really understand how these things relate. So we mentioned the longer the blood vessel, the greater the peripheral resistance. This will increase your blood pressure. If you increase the diameter of your vessel, that decreases peripheral resistance, that will decrease your blood pressure. Okay. If your blood is thick, okay, if your blood is thick, that increases your peripheral resistance, going to increase your blood pressure. Okay. This one we didn't directly mention, but this one should also make sense. Obstructions in your vessels, okay, these are plaques from arteriosclerosis. If it becomes harder for your blood to move through your vessels because of all of these obstructions, that will also increase your peripheral resistance, which increases your blood pressure. Okay. We said stroke volume and heart rate, that's how we determine cardiac output. So if either of these increases, your cardiac output increases, your blood pressure goes up. And your water volume, okay, aka your blood volume. If your water levels go up, your blood volume goes up, your blood pressure goes up. Okay, so again, take a look at this several times. Okay, make sure everything on this slide makes perfect sense to you.